Okay, we start again, and we are going to talk about pointers again very quickly. You should already know what a pointer is, and but let's have a little bit of recalling. Okay, so a pointer is basically a variable that can hold a memory address. So it's like any other variable, but instead of holding a normal value, it holds an address in memory. And so for example, here you have two integer variables, and then you have p, which is a pointer in memory to an integer. Okay, so this is the basic syntax: integer, then a star, and then p. Okay, and you can obtain the address of a variable by using this ampersand. Okay, this is simple. In Italian this is e commerciale, in English it's ampersand. So p equal ampersand a means that p gets the address of a. Okay, and of course you can print this address and you will obtain usually an hexadecimal address. Okay, and you can dereference the value. That means instead of printing the address, I want to obtain the value in the location at the address contained in p. So p as an address, we go to that address and we take the value. Okay, and that value is going to be an integer. We know because this is a pointer to integer. Okay, and we can use that writing star p also to the left of an assignment. So star p equal to 6 means that in the address pointed by p we write value 6. So now variable a is equal to 6 with this. And we can also change the value of the address. Now p points to b, and we can now print the value of b, which is 7. Okay, so pointers are very powerful because they allow you to do whatever you want, basically, because by having access to the raw memory you can do whatever you want. And there is an equivalence between array and pointers in the sense that the name of array is equivalent to a constant pointer to the first element in the array. Okay, so for example, I have here an array of characters name with my name, and if I do cout star name, as I said, name is also the pointer to the first element of the array, so cout star name will print g. Okay, and of course I can define also a pointer p that points to the first element of the array, like that. And what I can do then is to increment this pointer. Incrementing a pointer is equivalent to moving to the next location in memory. Okay, so this p now will point to I, the second character in the array. Okay, and this assertion is correct because in effect now p points to the second element in the array, so to name plus 1. Okay, and we can print the rest of the array by doing like this. So basically, until we reach the last element of the array, which is character 0, every string is always terminated by a 0, then we just increment, we just take the p, the element pointed by p, and we print it, and then we increment the pointer. Okay, so it just prints the content of the address pointed by p and increments it until the end of the array. Okay, so what pointers are for a lot of different things, you know, and but very often in C++ they are used for pointing to objects that have been allocated dynamically. Okay, so dynamic memory in C, there are two functions from the standard library. malloc and free that you use for allocating and deallocating memory from the heap. Okay, they both take pointers to any type. So malloc will take the sides of the memory to allocate and will return a pointer to void, and free will take a pointer to void. And this means that it's the responsibility of the programmer to make sure that is correctly using malloc and free. And actually this is one of the most difficult part of programming in C, is to make sure that dynamic memory is allocated and deallocated correctly. Okay? In C++, instead of malloc and free, you use two different keywords. Actually, they are operators. And you use operator new, and to deallocate you use operator delete. And they are more type safe, because new is going to look at the type of the object you are going to create, and delete is going to look at the type of the object you want to destroy. New and delete can be applied to primitive types, so you can allocate memory for integers, or to classes. Okay? And this new operator automatically calculates the size of the memory to be allocated, so it's also safer for this reason, because the calculation is done more or less automatically. So here, new int 5, it creates a memory for one integer and initialize this integer to 5, to value 5, and the address of this integer is stored into P. And then you have a class here, and if you do new A, this is actually two different operations. First, it allocates memory for an object of class A, so it calculates the size of A and allocates memory on the heap for an object of type A. And then it calls the constructor of A on that memory for initializing the object. The address of the memory is of the memory block is returned by new, and in this case is assigned to pointer Q, which is a pointer to an object of type A. And if we want to deallocate, we just write delete P and delete Q, and delete Q in particular does two things. First, it calls a function called destructor for class A, and then it deallocates the memory pointed by Q. So now let's see what is this destructor. So the destructor is just the dual, the inverse of the constructor. The constructor is used to initialize the object. The destructor is used for cleanup. Okay? So destructor and constructor are always defined for all objects. Okay? If you don't define them, the compiler is going to create standard ones for you. Okay? And the syntax for the destructor is that you have to put this symbol here, tilde, in front of the name of the class, and then here you write the code for the destructor. The destructor, of course, never takes any parameter. Okay, there is no need to pass parameter to the destructor. And here is the example. Okay, so basically I'm declaring a class A, which has one single variable A, and I have a constructor, and that takes an integer and initialize the internal variable with this integer, and then prints constructor on the screen. And I have the destructor, which basically tells us that we are destroying this object. And here what I do is a function that returns a pointer to an object of type A. And this function creates a local object of type A. Then it creates dynamically an object of type A initialized to 2, and another local object initialized to 3, and then it returns P. And then in the main, I'm going to create yet another object of type A, initialized to 0. I'm calling my phone. Then I'm creating still another object of type 4, initialized to 4, and then I'm deleting the pointer. So let's try to guess what's the order of the different printing I'm going to have in my program. So there are no global variables. So the first thing is to execute the main, and so the first thing is going to be printed is in the main. Then the constructor of this object is called. So the constructor is this function, so it will print constructor with a equal to 0. Then my function is called. So we go inside my function and we print inside my function. Then constructor of a is called, and this will print constructor with a equal to 1. Then another constructor is called, and then yet another constructor is called. So this will print 1, 2, and 3. Then we return. At this point, this function is finished, has terminated. So we have to deallocate the object on the stack. So what is going to happen is that the destructor of these two objects is going to be called. And in particular, the order is going to be the reverse order with respect to the creation. So this is going to call destructor of 3 and destructor of 1. Destructor of 2 is not called because this object is created on the heap. So its lifetime is longer than the local variables here. Then, again in the main is printed on the screen. Object 4 is created. Then I delete P. So I'm going to delete this object here. So I'm going to print destructor with a equal to 2. And finally the main is over. And so the destructor of 4 and the destructor of 0 are going to be called. Let's see if everything is correct. So in the main, constructor with 0, then constructor with 1, 2, 3, then 3 and 1 are destroyed. I return inside the main. I construct object with a equal to 4, then I destruct the one that I dynamically allocated here with delete, and then I destroy 4 and 0 in the reverse order in which they have been created. Okay, so this should show you when the destructor is called. The destructor is called either when I do delete, explicitly delete an object that has been allocated dynamically with new, or when an object that has been created on the stack goes out of its lifetime, so it finishes its lifetime. So in this case, x and y are destroyed when function myFun returns. Why we need a destructor? Until now, the destructor has done nothing but printing something on the screen. Well, a destructor is useful when an object internally dynamically allocates memory. In this way, when I delete the object, I also delete the dynamically created object. So for example, in this case, I have a class A, then I have a class B, which internally defines a pointer to A, and for example, in the constructor, A is created and its address is assigned to P. Well, we need to write a destructor to delete this object when B goes out of scope. Otherwise, some memory could remain allocated and cannot be deleted anymore in the future. Okay, so we need to take care of the objects that are dynamically allocated and manually deallocate them when they are not needed anymore. If we don't write this destructor here, the compiler will generate one automatically, which does nothing. And this means that if this memory is not deallocated properly, when an object of type B goes out of scope, we actually lose the reference to this memory, and so we have what is called a memory leak. Okay? So to avoid memory leaks, always remember to deallocate objects that you allocated during your lifetime. Actually, this way of programming is quite bad. And in the rest of the course, in this course, I hope to convince you to try to avoid this way of programming and to use instead some library functions, programming techniques that will help you avoid memory leak problems like this. Okay? So remember that you have to deallocate things, and in this course we will study techniques for automatically delete things like that when they go out of scope. Okay? So let's write a very simple piece of code in which we show what's going on. Suppose we forget to write this destructor, we just initialize P using the initialization list to a new object of type A that uses that's initialized to 7, for example. Okay, I'm going to write it down here. Okay, and now suppose that in the my function we also create an object of type B. Okay. What happens is that unfortunately we will see constructor with A equal to 7, but will not see destructor with A equal to 7. So see here you see constructor with A equal to 7, but you don't see destructor with A equal to 7 because we never really deallocated them. So to force the allocation, what we have to do is to write a destructor which takes care of deleting P. Okay, so we compile, and now we have destructor with A equal to 7 just before going out of the main function, of the my phone. Okay, and actually it's at the time of this destroying B we also destroy A. Okay. We can use new also for allocating an array of variables or an array of objects. Okay, for example, here we create an array of 5 integers. We use a square parenthesis here, and this will allocate an array of 5 integers. Okay, and these 5 integers are usually I don't remember actually what happens with primitive types. I have to admit I don't remember. Maybe we should try something. But it should initialize all these integers to 0, if I remember well. And when I want to delete an array, I have to use a special syntax. I have to say delete, then this square parenthesis, and then p, which is points to an array. So I have to tell the delete operator that I'm going to delete an array of elements and not just one single object. And I do the same with the classes, of course, exactly the same. Okay. Notice that in the second case, for sure, the constructor of A is called for every single object is created. Okay. And this means that you need to have a constructor with no arguments, because you cannot pass arguments to these constructors here. Okay, so you need to have a default constructor which takes no argument for constructing A, otherwise this will give you an error. And delete is just the same. You just delete an array of objects of type A. The address 0 is not valid address, and this is the same as C. So no data and no function can be located at 0. So therefore, in C++, a pointer to 0 is usually called a null pointer, which means a pointer that points to nothing. Okay? Dereferencing a null pointer is always an error, a very bad error actually, and is a so-called null pointer exception, or more generally, a segmentation fault. In C, you actually use the macro null to say 0, or a pointer to 0. The problem with using a macro is that 0 has no type, so it can be an integer, it can be a null pointer, it can be anything. In C++, they try to solve this problem of typing by using a specific constant, which is called null pointer, which indicates a null pointer and cannot be automatically converted to an integer. Okay, so this will catch a little bit of errors sometimes because it's not possible to convert 0 in the sense of a null pointer to 0 in the sense of integer. Okay, so maybe you already noticed that in C++ you can have several functions with the same name also in the same class. And this happens because you can do what is called function overloading. So in C++, the argument list is part of the name of the function. This means that if you have two functions with the same name but different argument list, for C++, these are actually two completely different functions. Okay? So, if you look at the internal name used by the compiler for a function, it actually consists of three parts: the class name, the function name, and the argument list. So this means that the function f of class A, the compiler internally will transform this in something like that. So basically it prepends some strange character, then the name of the class, then the name of the function, then the type of the argument. And if you have two arguments, this is like this is like that, this is like this. As you can see, internally, these are all different. So for C++, these four functions are all different functions. Okay? Now be aware of the type. Be very careful about these integer types here. Okay? Because there are some strange rules when you want to convert from one type to another one. So let's see which one is called. Suppose you have class A and class B. And class A defines three functions of type f, with name f, and class B defines one single function f. And you have two objects, A and B, and we write a.f of 5. So which function is called? Of course, is the first one. Okay? And then suppose that you do b.f of 2, and of course this is going to call this function. and then a dot f of 3.0. Well, of course, the third function of a is going to be called. And then a dot f by passing 2 and 3. This takes 2 arguments, so the second function of class A is going to be called. And finally, if I do a dot f of 2.53, well, there is no function that takes a double in an integer inside A. And so a sort of automatic conversion is going to happen. 2.5 is transformed into an integer, and so the second function is going to be called. Okay, so be aware of the type. Notice that return values are not part of the name, and the compiler is not able to distinguish two functions that differ only on return values. So if you have class A and you have two functions, floor, one that returns an integer, another one that returns a double, this is a compilation error, compile time error, because the compiler is not able to distinguish these two. In other words, the internal name is going to be the same. Okay? And this means that it's not possible to overload a return value. And the reason is clear, because the compiler decides which function to call based on the argument list, and not on how the return type is going to be used. Okay? So there is no way of distinguish between these two. So this is ambiguous, and so it's a compilation error. Things gets more complicated because sometimes functions have long argument lists, and most of these arguments don't change very often. So people like to set default values for arguments. So C++ allows you to say that some argument, if not specified, has a very specific value. For example, here function f has two arguments, a and b, but if I call f by passing only one argument, then automatically the second argument takes 0. Okay, so this is equivalent to f12 0. And of course you can also call f with two arguments. In that case, the value pass is the one that is used. Now, the combination of overloading with default arguments can be very confusing for programmers. So it's a good idea to try to avoid as much as possible overusing overload and overusing default arguments. So when you can, try to reduce to the minimum the use of default arguments and the use of overloading. Okay. So this is pretty much a very quick overview of basic things. Next time we are going to continue the overview by talking about references and by talking about copy constructors and things like that. But today I would like to start a sort of very simple exercise. In particular, we are going to design and use a stack of integer. Okay? So I want to write a class that defines a stack of integers. Okay, so this is going to be the interface of my class. I'm going to define a stack, and I want to initialize the stack by specifying the maximum number of elements in the stack. So max size is the maximum number of things I can put on the stack. And I'm going to use three different functions on this stack. Push to push an element, pop to remove the element at the top. Then I'm going to use peek to just look at the top, and then sides to return the current number of elements stored inside the stack. Okay? So I'm going to start it, and later on we are going to work a little bit on it to see the different way of implementing a stack. And actually we carried on this example for much of the course. Okay, so I'm going to define the interface first. Okay, so I leave the implementation empty by now. Okay, so right now it was very simple, and I need to complete here, and so I need to understand what to put here. So basically, as a first try, I'm going to use an integer, a pointer to a place in memory where I'm going to store all the elements in the array. Okay, so I need to create this memory when the stack is created, and of course I need to destroy, deallocate this memory when the stack is destroyed. Okay, then I'm going to use s, which is the number of elements in the stack, which is also going to be used as a pointer, index to the top element in the stack. Okay, so this of course needs to be initialized to 0 to mean that the array is empty, and then I will always index the first free element. Okay, now I'm going to create the implementation, and this is going to be in a C++ file. Okay, and finally I'm going to create a main file in which I'm going to test the array. So this little project will consist of actually 3 files: stack.hpp, which contains the interface, stack.cpp, which contains the implementation, and main.cpp, which contains the usage for this stack. Okay. So of course I want to create a stack, for example with maximum 5 elements. Then I want to push, I don't know, a few numbers in it. Okay, so I'm pushing 2 elements, and then I'm writing a code that prints the top of the stack and then pops it. And then I do this until the size is greater than 0. When the size is equal to 0, I just finish and I do. Okay? Let's try to compile it. We will get some error, of course, and but let's see what happens. Okay, so the first thing we do is to compile stack.main.cpp to obtain a main.o. So -c means that I'm just compiling. I don't want to link, so I don't want to obtain an executable file, but just an object file. Okay? So the output is going to be a main.o. Okay, so the first error I get is that cout was not declared in this scope. And in fact, I forgot the standard specification. So actually I should write something like this and this. Okay, because otherwise it doesn't know where to find it. Okay, or alternatively I can use using namespace standard here. Okay, this has compiled. So that's strange, no? It's as compiled because what is important is the interface of stack, and the interface is respected. So I'm using stack in an appropriate way, of course. And but stack, the implementation has not been done yet. Okay, so I'm not really compiling anything. And let's see what happens if I compile a file stack. Also, this works okay because there is no error, so everything goes okay. The problem comes when I try to link everything. So this means instead of compiling, this time I'm linking. So I pass the object files and I want to produce an example executable file. Okay? And here I see the problem. When I try to link, it doesn't find the implementation of the constructor, it doesn't find the implementation of these functions, and so basically it cannot produce an exec file because some function is missing. So now we need to implement these functions. Okay, let's start from the constructor. So what I do is I copy this here, I prepend stack to all of them, okay, and so now I have to implement. Okay. So these functions are going to be all very easy because this is a very simple implementation. But it already highlights some of the problems. So basically the first thing I need to do is to allocate memory for this array. So this allocates an array of integers, of max size integers, and the pointer is assigned to variable array. Okay? Then I also initialize s to 0, and as you will see, we actually will need this very soon another variable, but let's postpone this later on. When I delete, I need to delete everything. So I'm going to delete the array. When I push, what I do is I assign at location s into the array variable x, and then when I want to pop, I have to decrease s simply. When I want to pick, I have to return the value of array s minus 1, and size will just return s. So the implementation was quite easy, and this is a simple stack. You probably have seen this already many times. So now I'm going to compile to see if I made some mistake. I'm compiling stack. Okay, everything worked. Now I'm linking everything. Everything works, and now I can run example. And yes.
Sorry, you forgot the S++ in the bash.
You are right. Here we go. Thank you. And in fact, it was not printing anything. And okay, we compile and we run, and now I should see have something. Okay, 3 and 2, which are the elements I pushed in the reverse order. Okay, so here is it. I just push 2 and 3, and then I pop heavy elements. Of course, this was a very stupid implementation, and actually I forgot one thing which is very important. Can you tell me what I did not do that is very important? So where is the problem in this program?
Delete every element of the list, the stack.
Delete in the sense of what?
Maybe it's not enough the delete array in the structure.
Yeah, this deallocates the memory.
Maybe it allocates only the array and not what is complete.
But what is inside the array is just integer values. And of course, these are deleted when I unlink the block. I mean, I don't need to write 0 in the array, because who cares? This block is going to be reused later, and probably because it's going to be overwritten by some other part of the code. So I don't really care to delete in the sense of writing 0, I guess.
The size of array, the push. Matrix size. You're not checking the maximum size of the
Exactly. So I'm not checking anything here. So this is very bad, because if I give this to a user, he just uses it. And maybe if he makes a mistake, for example, if he tries to push too much, then what is going to happen? Well, what is going to happen is probably memory corruption. So I'm going out of the boundaries of this array, and of course nobody is going to tell me anything about it, and so probably this is going to cause some trouble in some part of the program in a very random way. In particular, let's look what happens if I write this. So I'm pushing 10 elements, but the stack only contains 5. What do you think will it happen?
Maybe nothing, because it tries, but...
Sorry, I didn't really compile main. I forget. What is it? Here we go. Then linking. Well, nothing is a bad word. So this is basically a segmentation fault, and this is some printing about what's going on in the heap. Okay, so basically the fact that I'm going outside of the boundary array was was catched by the library, the standard library, and it just raised an exception. And so we have this very bad error here. But this is not always the case. Sometimes you can have a very strange behaviors. Okay, so another core dump. It's not easy to obtain no error, but in some cases you can actually have no error. Okay, so it's going to be a very bad error. So anyway, we need to make sure that the user doesn't make any mistake like that. Okay, so first of all, we need to store this variable max size somewhere. Okay, and I'm going to initialize this. Okay, and when I push it, I first make sure that S is strictly less than max size. Okay, so if S is strictly less than S max size, I do this. Otherwise, what should I do? Well, there must be a way to communicate the error. We have not seen exception yet, but the most typical way in C++ to communicate this kind of error is to throw an exception. So I'm throwing an exception, which is actually an object of type string. To mean that I'm pushing too much. So if S is less than max size, it's okay. If it's equal to max size, I cannot do anything. Okay? And pop, I'm decreasing S. But if I do pop and S is 0, this is an error. So again, I have to check. If S is greater than 0, I can decrease. Else, I have to throw an error. And peek, again, if S is strictly greater than 0, then I can return an error, a value. Else, I have to throw an exception. And the sides, I just return the sides. And in the main, what I do is that I have to wrap everything into a try catch. Okay, and now let's try to compile. What happens that this function is going to be executed, and if there is an error, this will jump out of this block and go inside the catch block and print the string that has been thrown by the error. Okay, so let's see. Sorry, I have to compile first. I did an error, sorry. Max. Oh, sorry, this is M size. Okay, so exception has been thrown and stack is full is been printing on the screen because I catch the exception because I was trying to push more than allowed. Okay? Okay, for today that's it. We will continue tomorrow. If I remember well, we have a lecture at 4:30, right? And so for today that's it. Thank you very much and see you tomorrow. Bye bye.